Okay, so let's continue with our coding exercise series. So open the leetcode.com and go to the problems tab. And in the search question number 48, hit enter. So you will see question number 48, rotate image, and it's come under the medium category. So click on it. So basically the question says rotate image, but it's a matrix because our image is also a matrix only. So that's why they mentioned rotate image. But anyhow, so let's read the question. So you are given an n cross n. So just read the question carefully. It is not m cross n. It is n cross n. N cross n means the number of rows and the number of columns should be equal because n and n, row and column are both are same. So it's a square kind of matrix. The 2D matrix are representing an image. So there's a 2D matrix given. We need to rotate the image by 90 degree. So we need to rotate the image 90 degree, but 90 degree should be in the clockwise direction. So like this. Okay. You have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not allocate another 2D matrix and do the rotation. So what they mention is we need to do the rotation in place. Like you need to kind of swap some elements. It means you cannot consume extra space. So it doesn't mean like you can okay create some temporary array and okay, if I rotate this image then one will be here, then you are placing all the elements. No, we have to do in place. All right, so that's why like if you see the uh, function definition, the return is none because we don't need to return anything because we are doing in place. Even in the like dog string it is mentioned, do not return anything, matrix modify should be in place. Okay, so let's see what is the mm, first try to visualize the. So we have this matrix given 1 2 3 4 5 6 7 and 9. Okay, if we rotate 90 degree, so what will happen? So if we rotate 90 degree, 1 2 3 will come here, 4 5 6 will come in the second column, and 7 8 9 will come in the first column. All right. Okay, so let's go to the whiteboard. So how it will come? So we have 1 2 3 4 5 6 7 8 9, right? So if we rotate by 90 degree, what will happen? So one will go here, two will come here, three. So basically the whole row, the first row. So if we just rotate this, so 1 second. So if we just rotate this, like what is the clockwise? So clockwise is like this. All right. So like this. So we have to just rotate. So whatever right now here, we have to down here. So this is the clockwise direction, right? And whatever is here, we have to rotate above. All right. So that's why 7 8 9 will come up here, and 1 2 3 will come here, and 4 5 6 will come here. So we have to rotate 90 degree, and this is our output. Okay. So we have some like if you see our input, we have matrix is given. So matrix is a list of list. So list of list and which contains integer. So in our question, in our input, so matrix will be given like this only. So let's suppose like we have three rows. So 1, 2, 3, and in the second row 4, 5, 6. In the third row 7, 8, 9. So each row is a list. Each row is a list. So it's a list of list. All right. So this is given. And what we need. So when we rotated, so what should be the outcome? Because when we rotated, so what will be the outcome? 7 4 1. So instead of 1 2 3, it should be 7 4 1. The next row is 8 5 2. Then next row is 9 6 3 9 6 3. Then how we are going to convert this 1 2 3 4 5 6 7 8 9 2 7 4 1 8 5 2 9 6 3? So we have to find some logic, right? So one easy approach is, so like we have 1 2 3 4 5 6 7 8 9. So there is a two-step approach in one of the method. The first method is two-step approach. First is we can do the transpose of the matrix. Transpose of the matrix. Transpose means, so what is the transpose? Transpose means the row will become column and the column will become row. So 1 2 3 right now is a row. 1 2 3 is a row. So if we have to convert this row into a column, then it will be 1 2 3. 4 5 6 is a row. We can convert it to column 4 5 6. 7 8 9 is a column, so we can convert 7 8 9. All right. Now if we just transpose means like basically like 1 is at 0 0. So how we are going to fetch any element of the matrix, like matrix of 0 0, because first row is 0 and column is also 0. And how we can going to represent this element? So row is still 0 but column is 1. And how we are going to represent 3? A row is still 0 but column is 2. So 0 0 0 1 0 2, and this one row is 1, column is 0 1 0 1 1 1 2 2 0 2 1 2 2. So we are going to represent this. So basically when we are going to transpose, so I and j is going to also swap. So 0, I is 0, j is 0. So if we swipe, so it will again become 0 0. So that's why 1 is still here. Now 0 and 1. So now we need to convert, we need to like change row to column and column to row. So 0 and 1. So right now row is 0, column is 1. If we have to convert, so row will become 1 and column will become 0. So it's 1 0. So it means 2 will go at 1 0. So what is the 1 0 position? So this is the 1 0 position. This is the 1 0 position. So 2 will come here. Similarly, 0 0 2, so 3 is at 0 2, row 0 2, and the column 2. So now we need to do the transpose. In case of transpose, row will become 2, column will become 0. So it will be 2 0. So what will be the 2 0 location? 2 0 location is 3. So that's why it will come here. So basically we can scan all the elements and we can just replace ij to ji. All right. So matrix of ij and to matrix of ji. So we can do the transpose. So now once that, because there could be one question, can you do the transpose of the matrix? So this is the half of the question. All right. So we can do the transpose in such a way. So once we do the transport, what will be the output? So output is 147 147 258 258 369 369. But what we need the output? We need the output 741 852 963, which is not same. But then if you like closely observe, we need 147 and we have 741. So elements are same, but these are shuffled. We need 258 and there is 852. We need 369 and there is 963. So if we just reverse this, 147 to 741, 258 to 852, 369 to 963, then we are going to get our output. So this reverse part is very easy. We can just like scan our element. We just reverse the list and store it, reverse the list and store it, reverse the list and store it. That's it. So we will see how to do the, so this is a two-way process. First do the transpose, we will get the transpose and then we just reverse the all the elements. So let's try the question. So we can solve here directly, not in the pie chart. So first what we have to do, we have to scan all the elements. To scan all the element in a matrix, how you are going to scan all the elements? So let's suppose if I told you, can you print all the elements of the matrix? Can you print 1 2 3 4 5 6 7 8 9 10? So to scan all the elements of the matrix, you need to run two for loop, because there is an array. So you have you to print 1 2 3. So there should be loop on this, and there should be loop on the outer list as well. So basically two for loops, right? So to scan all the elements, we need two for loops, right? Okay, so let's try. So n is equal to length of matrix. So it will give either you row or column, because in our case it's a square matrix n cross n, so it's okay. Now we have to do transpose of the matrix, right? So to transpose of the matrix, we have to scan each and every element. So each and every element. So generally, how we are going to scan each and every element? By using to loop for I in range of, what you can say, for row in range of n, and for column in a range of n. We generally print like this, right? Print matrix of row and column. We can put row or column, or we can take ing variable. That is fine. Okay, so we are going to scan, we are going to print all this element in such a way, right? But in our case, what we have to do, to do the transpose. So it means we need to change I to j and j to I. So how we are going to change? So we don't need to print, but what we have to do, matrix of, so in Python, how to do the swapping. How to do the swapping. So let's suppose A is equal to 5 and B is equal to 10. Now we have to swap. So how you are going to swap in a single line? A comma B is equal to B comma A. Alright, so this is the way you can swap in the Python. Similarly, we have to do the same thing. So it's at 0 0. We need at 0 0. So it's at 0 1. We need at 1 0. So similarly, the same way we can do matrix of. So I can delete this or let it be for the time being. So matrix of I and J. Alright, so we need to swap matrix of IJ, matrix of JI. So we need to swap these two elements. So what will happen? Matrix of JI, comma matrix of IJ. So this is the method to swap. But if you just run this and let's not even run, let's print the matrix. Let's print the matrix. This is not complete because we are just doing the transpose, but transpose is also wrong. I will tell you just a very minor mistake. So let's run. So now, oh, I am taking INJ, or let's take INJ. So let's run it. Basically, I is a row, J is a column. Okay. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We did the transpose. So we are expecting 1, 4, 7, 2, 5, 8, 3, 6, 9. Anyhow, like let's just forget the actual output. But for the transpose output, it should be 1, 4, 7, 2, 5, 8, 3, 6, 9. But what we are getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 8, 9. The same matrix we are getting. Even after the swapping, we are getting the same matrix. How it is possible? How it is possible, right? So if you observe clearly, so let's suppose you are here initially. You are here initially at 1 1. So you swap 0 and 0. So it will come at 0 and 0, which is fine. Now you come at 2. Now you would come at 2. So 2 is at 0 1. You have to put 1 0. So 2 and 4 are going to be swap. So 4 will come here, 2 will come here. Okay. So 2 will come here and 4 will come here. Okay. So right now 1 and 4 are here and 2 is here. Now we will come 3. So 3 and 7 will be swapped. So 7 will become here and 3 will become here. Right. Now we will pick this element. But here we have the 2. We have the 2. Now we have to swap again this element. So if we swap again this element 1 0, we are going to swap with 0 and 1. So it means we are again swapping the same element. So already we swapped 2 to 4. So we should not pick this element, because when we come to the second iteration, we should not come pick this element, because if we pick this element, again 2 will go to its original position and 4 will again come to the original position. So that's why at the output we are getting the same matrix. So instead of this, so what will happen? We will scan all the rows. So for rows, we will scan all the 3 rows. But for the columns, so we pick first column. So 2, 3, which is fine. So, but when we come here, are we going to pick 4? No. So if we are not going to pick 4, what column we are going to pick? So the second column. The second column we are going to pick. So here, what we have to do when we are going to pick the column, so here we are going to start from the I plus 1. I plus 1. So now if you run it, what is happening? Okay, let me rerun. Unknown network error. Yeah, and so now you could see 1, 2, 3, 4, 5, 6, 7, and 9. So we have 1, 4, 7, 2, 5, 8, 3, 6. And now it is the actual transpose, right? Because if you are not going to pick I plus 1, so n and n is fine if we have to scan all the elements. But in this case, if we do the transpose, we scan 1, we scan 2, we scan 3. So when we scan 2, it come already here. So now if we scan again this element, again, so now it's here 2. So at this position 2 will come, right? But if we scan again this element, then again we are going to transpose, right? Again we are going to swap. So it means we need to skip that element. So to skip that element, so we have to do I plus 1. So now we have 147, 258, 367. So now what just we have to do? We have to reverse this because the actual output is 741. So we have 147, we need 741. We have 258, we need 852. We have 369, we need 963. So what we will do now? Just reverse the list. So for so we have currently we have this right. So we will scan all the elements for I in range of n. N is like 3 for I in range of n. So when we do first iteration, what will come? So matrix of I means matrix of 0, matrix of 1, and matrix of 2 will come. So matrix of 0 currently 147. Matrix of 0 currently 147. So we need to convert the whole matrix. So we need to convert the whole matrix. So matrix of 0 we need to convert. So what will be the matrix? So matrix of I is 0. I matrix of 0 is 147. So this is a list. So how you are going to reverse the list? -1. That's it. So now we pick the element and we place at the same position but by reversing it. So now instead of 147, we will get 741. Instead of 258, we will get 852. Instead of 369, we will get 963. So let's try to run it. So our sample cases has been accepted. Let's try to submit. So you could see like the solution has been accepted and all the test case has been passed. So this is the like simple solution. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9. What we can do, we can do first the transpose. So how to do the transpose? So transpose means row will become column, column will become row. So it means we just need to do the swapping, and we know how to do the swapping. So this is the way. This could be the only tricky part, and we can even like even though when I like solving this problem, so I just put the n. Then we realize we are unnecessary like swapping the same element again and again. So if we swap the same element again, then we are finally we will get the same output. So that's why we have to put I plus 1 here. And after that, like this will be very easy part. Once we get the list, we have to just reverse it. Right. So there could be like many ways. So this is the one way which I feel the easy way and straightforward, not very much complicated. There could be like one more way. Maybe you can Google it. So the way is because this one where we are putting here. So it means okay, let me rub it. Let me rub it. So this one we are putting here. All right, so here this 3 we are putting here. So 3 is here, and this 9 we are putting here, and this 7 we are putting here. All right, so you could see 7 we are putting here, 1 we are putting here, 3 we are putting here, 9 we are putting here. Similarly, 2 we are putting here, 6 we are putting here, 8 we were putting here. All right, so this question can be solved by this way as well. You don't need to transpose, you don't need to do this. But in that case, what you have to do is you have to take 4 variables: first variable, second variable, third variable, fourth variable, and then you need to save this variable. And once you save this variable, you can put 7 at this position. 7 at this. So once you save this variable, so you put 7 at this variable. So now 7 already places. Now you put 9 at this place. So now you put 3 at this place and 1 at this place. And then again, like you can iterate I. So that I feel like a little bit complicated, but that is also an easy solution. But for the time being, like this is easy, this is also easy. And if we solve this question now, one more question can be solved. Like if someone is going to ask, can you do the transpose of the matrix? Because transpose of the matrix is also the one of the question. So that question also covered in a like in our this problem rotate image. So that's it. That's the end of the video. You can also try this question. Thank you.